Welcome to Module 2, Chapter 2 from our book on weather. Before we get going on that, sometimes I like to have a little inspirational quote. So this week, our quote is from former President Ronald Reagan. In his first inaugural address, he said, "It is time for us to realize that we're too great a nation to limit ourselves to small dreams." This is something that needs to be remembered these days. We're a great nation. We're very blessed. We have many great opportunities. We have challenges. We have things we still need to improve on. There's no doubt about that. Some people these days only see the negatives. They harp on and harp on and harp on how bad we are, instead of realizing how far we've come and appreciating that, and then looking forward to how we can make things better. And, we need to personalize this in our life. We need to appreciate our opportunities and continue to take hold of those opportunities and turn them into something great. So let me put it this way. You live in the greatest nation in the world. We do have an immigration problem, and there's a reason why everybody wants to live here, because it's freaking awesome, right? America is a wonderful place to live, and that's why so many people want to come here. It's a place of great opportunity. But you live, if you're most of you that are watching this live in California, which is the 8th greatest economy in the world. And there's another reason why people want to live here. Now, we're living in a time when a lot of people are moving out of California for a variety of reasons, but one of them is our taxes are getting so high. But that's a political subject for another day, maybe. But not only that, most of the people who are listening to this live in the Ventura County, which is rated by Gentleman's Quarterly, was rated the #1 city in the whole United States to live in. So we're in an awesome place, right? We have a great opportunity. So let me put it this way. I know some of the people in this class live in challenging circumstances. There's no doubt about that. And even though you have great opportunities, some of us are struggling, especially in this recording is being made during the COVID-19 challenge. Some of us really are going through hard times. I understand that. It's been hard for all of us, but some more than others. However, in this class, I guarantee you, the poorest person listening to this lecture is one of the richest people in the world. If you live in a home that has a refrigerator and there's food in it, and there's something on the floor other than dirt, and you actually have a way to get around, a vehicle, you're rich. You're rich in comparison to most of the people in the world. So don't limit yourself to small dreams. Dream big. Look forward to getting your goals accomplished. Do your best at what you have and turn it into something. Now, I took longer on this than I should have. Let's get going talking about weather. So, it isn't by mistake that the first of the 10 standard firefighting orders deals with weather. It's extremely important. It's the primary driving force behind the changes in fire behavior. Our other influences of fuel and topography are important, but let's put it this way. It takes us 2 weeks to cover this subject matter of weather. We cover fuel and topography in 1 week together. Okay? So this is really, really important to understand. If you are going to be able to base all actions on current and expected fire behavior, you've got to understand what is happening with the weather, because understanding weather is essential to predicting future fire behavior today and tomorrow. It's important that we identify the changes in the weather and understand what they mean. We understand what's going on in a cloud in the sky and what it indicates about today. Each year, weather changes, even subtle ones, are killing or injuring wildland firefighters. And we've got to be better at this. We've got to get better at understanding these influences. So the Earth's atmosphere is extremely dynamic. It's constantly changing. And this is a combination of factors, and we're just going to talk about the major influence on the Earth and how weather happens in this lecture. In the next one, we're going to start talking about wind, and that'll take 2 lectures to do wind. And then in the second week, we're going to talk about moisture and air stability and things of that nature. So understanding how the Earth's weather factors affect the big picture is necessary before you can actually understand everything. So I like to think of it in the 3x3 way of thinking. So this was in your handout, and I also included it in the overview of this chapter. So wind, temperature, and moisture are 3 major factors, and under each one I've put 3 minor factors. Now in our book it talks about 18 behavior factors, and you should know that because you need to know it for the book and for the questions. But I like to simplify things. That's my brain needs to put things in boxes. And so this is how I put it in a box. Don't be talking about 3x3 when you get on some crew, because they're not going to understand what you're talking about. Now you can share it and say, hey, my instructor broke this down this way, and this is how he thought we should think of it. That's fine. But wind, temperature, and moisture, and moisture to me is I put humidity and precipitation together into one group. The 4 primary weather factors that can affect the start and spread of a wildland fire are wind, temperature, precipitation, and humidity. Again, I put precipitation and humidity and call it moisture. So let's talk about the Earth and the sun. The layer of the atmosphere closest to the ground is called the troposphere. We don't need to get into the other parts of the atmosphere for this class, but maybe in science you remember the different portions of the atmosphere. But the troposphere is what is most important to us, because all weather phenomena happen within this 5 to 10 mile thick layer. The air within the troposphere contains oxygen, nitrogen, and some other things, argon and carbon dioxide. What's most important is you know that 21% oxygen is what's critical for us as human beings. When you start getting down to 18% oxygen, you are in an air deficient environment. You're going to start having headaches. You're going to start feeling odd. And if you get down to 15, 16, you're going to die. So that's generally, I don't remember off the top of my head exactly those numbers, but when you're in an oxygen deficient environment, it does affect you. And we've kind of talked about carbon dioxide, and we have to be aware of that on fires we do get a lot of carbon dioxide, and that's monoxide. I'm sorry, not dioxide. We get a lot of carbon monoxide, and that depletes our oxygen levels in our red blood cells. We have to be aware of that especially when we've been on a fire for a long time, that it affects our ability to think, and, can make us sick. If you start vomiting, you're having headaches, you're getting too much carbon monoxide, way too much. So let's keep going with how this all happens. So remember, the weather happens for us. What we're concerned about is in the troposphere, this 5 to 10 mile thick layer. Now, what happens within the troposphere all starts with the sun. So what's the ultimate source of all weather? the sun. It all begins with the sun. The sun is the weather engine. So from the sun, thermal energy comes out. Solar radiation energy is what causes changes in the Earth's weather. So the solar radiation comes towards us, the thermal energy from the sun, and it affects the Earth. So if you can see the solar radiation, so think of it as thermal energy within the sun is radiating out. And what comes to us is the solar radiation distribution. Now, it's affected by quite a few things. So it affects us, it strikes us on a 24-hour cycle. So roughly half the day you're getting solar radiation, half the day you're not, because it's nighttime, because the Earth is spinning and all of these kind of things. So we're going to talk about this. The amount of solar radiation that strikes the Earth is related to the density of cloud cover and many other factors. That's in another slide coming up. So to maintain a favorable climate, the daily outgoing radiation needs to equal the incoming solar radiation. We call this heat balance. So during the daytime and throughout the day, different amounts of solar radiation are getting through. So a cloud comes between you and the sun, and all of a sudden the temperature goes down some. The humidity might go up, but the temperature goes down. So this is all about solar radiation and how it affects the Earth. Now, as the solar radiation comes in, it hits the Earth and it absorbs it. And then it gives it back out. As this Earth is heating up, it gives it back out. And this radiation this solar energy, this thermal energy that is absorbed, is now given back out, and that is the outgoing radiation. So the sun's outgoing thermal radiation comes to the Earth and equals the incoming solar radiation, and then the Earth gives some of that out. It absorbs some, and it reflects or now gives out that same energy. That's very important that we understand that concept. So it gains heat during the day and then it loses it at night. And it's always gaining and losing. It's got some coming in and then or something going out. So this gain loss is what keeps us in. The Earth is always trying to seek a balance. So not all parts of the Earth maintain a balance, and the polar caps are going to lose more heat than they gain. So think about the fact that the Earth is constantly spinning. The Earth is spinning, and not only is it spinning, it's on a tilt. So some parts of the Earth get more solar radiation and some parts barely get any. But not only is it spinning and and on a tilt, but it is in a rotation around the sun. So the different times a day, the different times of year, the different points on the Earth are all going to be different. So the polar caps lose more heat than they gain. The equatorial region gains more heat than it loses. And this imbalance is what drives the dynamics and movement of what we call weather fronts. Hot air rising and cold air sinking, and these things are going on from the Earth as the sun radiation is coming in, and then some is radiating back out, and all of these things together create the Earth's weather engine. The solar radiation coming in, some of it going back out, the different points on the Earth, all of this is causing an increase and decrease in surface temperature from site to site, day to day, year to year, season to season, year to year. So the 4 primary factors that influence a change in the surface temperature, and we're going to talk about these 4 things. We'll be done with this part. The 4 primary factors are the amount of moisture or pollution in the air. We call that obscuration. So it obscures the amount of radiation that's coming in. And then the second one is the angle between the surface of the Earth and the Sun, as I just referred to. Then the lag time between the solar radiation striking the Earth and then coming back out. So I'm going to give you an example of that right now. Before we move on to that, we'll talk about it in more detail. What is the time of day where the Earth is getting the most solar radiation? Well, we call it high noon, when the sun is straight up and it's got a straight effect on that part of the Earth. Okay? Solar radiation coming down, striking it, hitting it hard. Is that the hottest time of day? Well, we all know that's not true. No. So the most solar radiation is not necessarily the hottest time of day, because 2, 3, 4 o'clock, somewhere around there, is the hottest part of the day. And so that's because it's the combination of the solar radiation coming in and that which is being reflected back out creates that hotter time of day. That's that lag time. And then lastly, the surface properties of the terrain and or the vegetation. We brought up aspect in the first couple of weeks, and we talked a little bit about aspect, and that is a big factor. Which way that portion of the Earth and what kind of vegetation it has on it is going to have an influence. So let's talk, number 1, about moisture pollution in the air. So the clouds and the pollution absorb and or reflect solar radiation. So one of the worst winters in recorded history, I forget the actual year, but there were 2 enormous volcanic eruptions in the Pacific. And these volcanic eruptions put so much pollution in the air that the Earth was not absorbing as much solar radiation. And that following year, there are records of horrible winter all throughout the world. It happened in the Pacific, but Europe was affected by it, all the whole world. And historians commented on it in every part of the world. So that volcanic ash that was up in the air was causing solar radiation not to get to the Earth. So the presence and thickness of clouds, water vapor, smoke reduces the amount of solar radiation heat that reaches and leaves the Earth's surface. Now, in some ways, it holds some of it in. Have you ever noticed when this quite often has happened where we live, where we'll get temperatures that are below freezing and we know that a storm is coming in and we think, oh, we might get snow. We rarely get snow, so it's an exciting thing here. Oh, we're going to get snow tonight. And the clouds move in and all of a sudden the temperature goes up above freezing and we get rain. And it's like, well, why did that happen? Well, the clouds, when they came in, the Earth is radiating heat off of it that it had been absorbing, and the clouds then reflect that back down and hold it in, and the Earth's temperature, the air temperature, goes up. So clouds and pollution can restrict solar and planetary radiation, filtering the incoming and restricting the outgoing. Now, the angle of the sun plays a big part in it too. So what latitude you're at, what slope a hillside, what's the percent of slope, what's the aspect, which way is the mountain facing, the elevation and shape of the terrain, all of these can change the Earth's temperature because of the angle of the sun to it. So that changing angle, influenced by the Earth's axis, by the spinning, by the topography, is what causes these changes in seasons and the amount solar radiation that's absorbed. So if directly above and at right angles to the Earth, that's the most energy that's going to reach the surface. But as the sun moves through its daily arc, the angle is greater. Thus, the radiation is reduced. So, think about the fact that we're in a summer path right now, but as we continue to move into fall, my favorite season of the year, that angle's going to change. And I've already noticed it's the end of August as I'm recording this, but our nights are starting to get cooler. Okay, we're still going to have hot days. We all know that September and October in California can be very hot, but our nights will start to be cooler because we're not getting as much solar radiation. So that third factor is lag time. Lag time is that amount of time that it takes for the radiation to then reflect from the Earth. So we're losing heat as well as gaining heat. And the incoming energy from the sun exceeds the outgoing energy around noon each day. But then as the day wears on and we continue to spin around and get at a different angle, now our temperature continues to rise because it's not only what's coming in, but it's what's going out. The Earth is receiving more heat than it is losing. The temperature doesn't start cooling off until the incoming energy ceases to be greater than the outgoing energy. And then somewhere between 5, 6, 7, we start to see the temperature usually go down. Sometimes in August, not. Therefore, though 12 noon is the time of maximum incoming radiation, 2 to 4 is usually the highest temperature. Okay, so here's an illustration of it, and I love this illustration. The minimum temperature is somewhere early morning, and then as the sun begins to rise, we get this incoming radiation being very high. Now, the maximum temperature is not when the maximum incoming radiation is. It's later, 2 to 4, when the outgoing radiation is at its peak and the incoming radiation is still high. Okay? So last little bit here, surface properties. The amount of solar energy reflected or absorbed by any surface terrain and or vegetation varies with its color and texture, with its transparency, with its conductivity, how much does it absorb or reflect out, and the absorbed heat. So, and this is also affected by the surface moisture. At the beginning of summer, our fuels are still green, and so they're not going to give off as much heat because they're still moist, and they're going to absorb and keep in that heat and not necessarily give it out. But as June moves on, we see our hillsides start turning brown, and no longer do we look like Ireland. Now we look like the desert that we are. So this is a process. Let me give you one final slide and a perfect example. Well, actually, there's 2 more slides, a summation slide. I was on a film shoot, and long story, I needed to check some surface temperatures because I did not want them to do the special effect under the conditions. It was a very hot day, so I have an infrared thermometer. Now, this is what I want you to notice. I am standing in the same place. I did not even move my feet. I just turned. Here, at 114 degrees, was the temperature of the leaves in the shade. 114. I turned and took a picture here, took a reading where I was showing where the leaves are on the ground in the sun. And it's almost 40 degrees difference just between shade and sun. Same stuff, same leaves from the same tree, not even 3-4 feet apart, in the shade, in the sun. 40 degrees difference. This is a very important thing to remember because aspect southern aspect and southwest and west get a ton of sun every day. Your fuels are hotter, therefore they're closer to their ignition temperature. This is an important concept to remember. Okay, last slide is kind of a summation here. So think about the solar radiation is coming down, and here it is showing you at different aspects with different kinds of fuel, water versus earth. All of these get different temperatures at the same time of day. So the solar radiation is coming in, and out on the ocean, it's 65 degrees. If you read the surface temperature on this south aspect, it's 95 degrees. Go to the other side of the mountain where there's more green, there's more growth, it's 75 degrees. 20 degrees difference easily from the south aspect to the north aspect. It can be way more than that. They're just showing 20. But then look at this. Flat surface, they call it fallow ground, like where a farm might be, absorbing the maximum amount of solar radiation, 115 degrees on the ground. There's an explanation of how the solar radiation is absorbed by the earth in different ways, in different parts, at different times of day, at different angles of the sun, during different seasons and different years. So we need to remember all of that as we move forward in weather. Thanks for your time. Sorry, I always try and make these shorter. I was shooting for 20 and I got 26. Okay, move on to wind. Take a little break before you do it. And don't forget, you can always put these at a higher speed so you can get through them faster. My voice will sound funny, but you'll get through faster.